All right, this is the second part of our lesson on set theory. Hopefully you've already watched the first part, which was basically the definitions and ideas that we need to understand what we're about to do here. This is just going to be a couple examples of how it works. And yeah, let's jump right in. So for the first one, we're going to take a look at the Justice League. I happen to be a huge superhero fan. Hopefully you're familiar with at least a few of these characters. You may not be familiar with them all, but that's okay. I'm just going to zoom in for a moment here. And what we'd like to do is just label each of these characters. Now, rather than use their entire names, I'm just going to use the first letter of each name just to make our life a little bit easier. And we're going to consider these the elements of our universal set. The universal set being the members of the Justice League, at least the ones in this picture, since there's been like, I don't know, 8,000 different iterations of the Justice League. In this picture, however, let's start off with the probably best well-known ones, which would be Superman in the middle, and then we have Batman and Wonder Woman and Flash. By the way, if you're not familiar with these characters, don't read too much into it. We can get most of the information we need out of the picture once we've labeled them all with a letter. Now, you might also be familiar with the guy second from the left. That's a Green Lantern, at least one of the Green Lanterns. It's not the traditional Hal Jordan. This is the John Stewart Green Lantern, but still Green Lantern. On the far right, we have a girl who looks like a hawk, and her name is Hawk Girl. And I do want to point out that her name is Hawk Girl because she looks like a hawk. I am not calling her Hot Girl, which I had a student mistake me for saying the entire class once and was very confused. On the far left is one of the more unknown characters, although he's been brought to life a little bit with the recent Supergirl TV show, and that is the Martian Manhunter John Jones. So we're just going to call him M. Okay, we've now given all the elements in our set letters, and from there we can fill out this little chart. Okay, so as I mentioned in the previous lesson, one of the very few reserved letters is a capital letter S, and it is used for the universal set, so we shouldn't call any other sets S. And that brings to question Superman. Is it a problem that we called Superman S? The answer is no, it's not, because we've reserved S as the only set to be called S. Superman S is an element within the set. So there's a difference between the sets themselves and elements within the sets. They can coincidentally be the same letters. It's just we can't have two different sets defined differently with the same letter. So to actually write out what the universal set S is, we're going to start by putting squiggly brackets. I'm actually just going to blow this up a little wee bit so it's a little bit easier to see. And do the best you can to draw your squiggly bracket. I realize mine just looks like a random nothingness. Looks like I just started scribbling from the top, and it's close enough. And then we're just going to list all the elements in our set. And just for ease of consistency, we're always going to go from left to right-hand side. So I'm just going to do M, G, W, S, B, F, H. And therefore listing all of the elements in our universal set. So now I've defined a whole bunch of other sets based on certain properties that these characters have. Most of them I think are going to be fairly obvious, but possibly not all of them. So some of them may require a little bit of understanding of superhero-ness. Yeah, let's use that term. But if you're, again, not familiar with these superheroes, just bear with me and I will talk you through it. Okay, so the first one, which are the characters that have capes? And again, I'm going to go from left to right and notice that Martian Manhunter has a cape. Green Lantern does not, Wonder Woman does not, Superman does, Batman does, Flash doesn't, Hawkgirl has wings but not a cape. So there is the set of caped members of the Justice League. And then we go to masks. Going from left to right again, we get nope, 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 nope. Batman, Flash, and Hawkgirl all do. Okay. Which one of these characters fly? Now, this is where some of you may not be familiar with all the characters. Martian Manhunter does in fact fly. Green Lantern does fly as part of his powers. Wonder Woman, I should point out, Green Lantern flies because the ring that he uses allows him to fly, just in case anyone wants to get in debates over these. Wonder Woman, in some iterations of the Wonder Woman comics throughout time, she has been able to fly, kind of like Superman, but for the most part, she does not fly unless she has an invisible jet. And if I had a jet, I could fly too. So I'm not going to include Wonder Woman in flying. I will include Superman. Batman, same thing. He flies in like the Batjet, but anyone can fly if they have a jet, so we're not going to include that. Flash, Flash does this weird hover thing he can do when he spins his arms really fast, but for the most part, I'm not going to consider him a flying character. And Hawk Girl, I'll let you take your best guess on that one, but I mean, she is a hawk, so I think we should include her. Now, again, if your answers for these, if you want to go into some comic and you want to point out in Justice League, issue 143, page 22, someone does something different than what I said, it happens. We're going to stick with these ones here. Which ones are girls? Now, you'll notice that I chose the terms girls and boys instead of male and female, specifically because I just defined masks and flying and used the variables M and F. So I thought I would use different variables and give them different, somewhat logical names. Okay, so the girls would be Wonder Woman and Hawkman. Hawkwoman, obviously. Um, the boys would be Martian Manhunter, Green Lantern, Superman, Batman, and Flash. The next one, Earthlings. This one, again, you may not be familiar with, but let's start from left to right. Martian Manhunter, he's from Mars, so he is not an Earthling. Green Lantern is an Earthling. He is definitely from Earth, even though his powers are from space. Wonder Woman, for those of you who don't know, she's not actually human, but she is from Earth. So we're going to put her in there. Superman is not from Earth. He is from Krypton. Batman is from Earth. Flash is from Earth. And Hawk Girl, actually, while she looks quite human, is from Thanagar. Not that you need to know that, but she is actually an alien. Okay, so now to list the aliens, I think we've already kind of worked through this. Martian Manhunter is an alien. Superman is an alien. Hawk Girl is an alien. Now we're kind of running out of... I'm trying to keep the picture on the screen while still showing the thing at the bottom there. I've listed bald and I've given it the variable Q, which is an odd choice, except that B was already taken for boys. Um, so this actually comes from a really bad, like, I don't know, joke or whatever, but people who are bald are sometimes called cue balls, which is oddly enough not spelt with a Q. It's spelled C-U-E, as in like a cue ball on a billiards table or a pool table. Shiny, round scalp. Anyway, we're going to use Q as our variable for B. And if we go through, Martian Manhunter appears to be bald. Green Lantern, while he is bald in some versions, he's clearly got hair in this picture. Wonder Woman has hair, Superman has hair. The last three have masks on, so you can't technically tell, but they do all have hair underneath. I think Martian Manhunter is the only bald person in the group. And then the last one, facial hair. Um, Facial hair we'll use an H for. And if I look at these carefully, Martian Manhunter has none. Green Lantern has none. Wonder Woman has none. Neither does Superman, Batman, Flash, or Hawkgirl. So no one has facial hair. And because of that, I want to write down that H equals a null set. So I'm going to do that with open and close squiggly brackets with nothing between them. But I'm going to point out that I could also have written down H equals null or H equals void symbol, which is supposed to be a perfect circle, as best that I've drawn it, with a diagonal line through it. Not to be confused with a zero. It's actually the void symbol. Okay. Which of the above are null sets? Well, there's only actually one that's a null set, and that's the facial hair. It's the only thing that has nothing in it, not because it's impossible for someone to have facial hair. Um, Null sets sometimes just occur because the particular group that you're looking at doesn't have the quality that you're looking for. Part C, list any pairs of the above set that are disjoint. I'm going to say now, you may want to try this a little bit on your own before we take up the answers. These are things like that we can now actually use thought process to get instead of just kind of definition. But assume that you've done that. I'm going to continue. I will mention that there are possibly more sets than I will list. I just want to list a couple to make sure that we understand what a disjoint sets are. Okay, so disjoints. Let's just start at the top. Cape and masks. Cape and masks both have a B in them. They both have Batman, so those are not disjoint. Cape and flying both have Martian Manhunter. They're not disjoint. Capes and girls. Capes and girls are disjoint. Capes has Martian Manhunter, Superman, Batman. Girls has Wonder Woman and Hawkgirl. Now, I want to point out that those are disjoint, but not necessarily complements of each other. They're not like one and not that thing. So it's not like capes and not capes. It's capes and girls just happen to be disjoint. So I'm going to put down capes and girls. Are there any others? Girls and bald. And bald is our Q again. So those two things have nothing in common. What about earthlings and aliens? And boys and girls. Those are sets that have nothing in common, no common element. Now, here's kind of an interesting one. Facial hair and everything. I'm not even going to list a specific one because facial hair and everything else are disjoint because H has no elements in it, so they can't possibly share an element. Now, usually we don't bother listing stuff like that because it's kind of redundant. It's two sets are disjoint if one of them is empty. Seems like an obvious thing, but it is true. Part D, list any pairs of sets that are subset of one of the others. Can we do that? Well, I'm going to start off with a smaller set because that's usually the easiest one to find is a subset of something else. Martian Manhunter is bald, and he's the only bald character. So he's going to be a subset of any other set that contains him. So Q is going to be a subset. And remember the symbol for that is like a sideways U that could kind of look like a C. So we can think of it as Q is contained within, and then any set that contains M. So capes, Q is a subset of flies. Q is a subset of boys. Q is a subset of aliens, and so on. Now, can we find any others? Are girls the subset of anything? Because that's another small set. W and H. Is there any other set that contains W and H? And honestly, I don't see it, but I may be missing it. I don't think so. Then we have our mask wearers, BFH. Is that a subset of anything? And I don't think it is. MS and B. MS and B, so our our cape wearers are all boys. So our cape wearers are a subset of boys. And then the last one I'm going to point out, again, this may not be all of them. It's really kind of time consuming to go through and check every possible combination here, but facial hair is going to be a subset of everything. For the same reason as before. A null set is always going to be a subset of every other set because it doesn't contain any elements that aren't in the larger set. Again, a little bit redundant, but eh. Okay, list pairs of sets that are complements of each other. Express this using proper notation. Okay, I'm going to be honest here. Rather than look at the elements of the set, I'm going to look at what their descriptions are and see if it makes sense that two things would be complements. Now, it doesn't mean there won't be a few that could coincidentally work out, but let's just see if we can figure this out by the complements. Now, if I look at boys and girls, those two are going to be complements of each other. Everyone in this group who's not a boy is a girl. Now, I will point out, just because I want to be sensitive to people who are part of the LGBTQ plus community, that I'm not saying that those are the only two binary things out there. I'm saying that within this set, those are the only two options. Incidentally, I should point out that DC in the Supergirl TV show actually did introduce the first televised transgender superhero ever, which is kind of cool. And it's also kind of well, it's she's an interesting character. I like her character. Anyway, so in this case, in this particular set, boys and girls are complements of each other. So what I can write down is girls are boys not, or boys complement. That would be the proper notation. Or I could write down boys equals girls complement, which is just saying that the complement of one is equal to the other. And similarly, one of our other two that kind of make sense are Earthlings and aliens. They're either from Earth, or aliens are basically defined as not of Earth. So Earthlings are not aliens, or aliens are not Earthlings. And now if we look here, there actually is one other complement set, which may not be super obvious. And that's that H, which is the null set, is the complement of the universal set, because when I put them together, they contain just the exact universal set. So it is kind of a weird one, but Q is not the universal set, even though is within the universal set. That's why the null sets always cause kind of weird stuff. Or S equals Q naught. Okay, now that we've done that, let's talk about some unions and intersections. And I thought I would put the picture there again just so we didn't have to keep referring upwards. And I'll just remind you that this is Martian Manhunter, Green Lantern, Wonder Woman, Superman, Batman, Flash, and Hawkgirl. Okay, so for this, we have to remind ourselves exactly what union and intersect mean. Intersect means that all criteria must be met. Union means at least one criteria must be met. So intersection is and, union is or, and it's one, the other, or both. Or in the case of our last one, A or B or C or two of those or all three of them. So just think of it as it has to meet at least one criteria. So now I could try to go back up to the actual set that I listed, but I'm just going to use the picture and logic my way through these. So what I mean by that is, which of these characters meet the criteria of having a cape or being able to fly, or possibly both? As long as they meet one criteria, they're in. So Martian Manhunter has a cape. Can he fly? Doesn't matter. He's already met one criteria. Green Lantern can fly, so he's met one criteria, even though he hasn't met the other. Wonder Woman meets neither criteria. No cape, not able to fly. Superman's both. Batman has a cape. Flash does not have a cape and does not fly. Hawkgirl can fly. Okay, now let's do the intersection of that. Intersection means they meet all criteria. Now I'm going to point out that the intersection of two sets is always going to be a subset of the union of the two sets. Because if the union is meets at least one criteria and the intersection is meets both, you can't possibly meet both without meeting either. So it's always going to be some of the ones from there. So I don't even have to consider all of them. I only have to consider the 5 on the left. So let's actually do that. Um, which ones have capes and can fly? Martian Manhunter can do both. Green Lantern, no cape. Sorry, he wasn't even in our list. Wait a second. I think I made a little goof there because Flash should not be before Superman. Did I write the wrong letter? Capes or flies? Martian Manhunter. Oh, that should be a G. My apologies. So that right there should be a G. Hopefully that's the only mistake I made. Okay, so Martian Manhunter meets both criterias. Green Lantern does not meet cape. Superman meets both. Batman does not meet flying. Hawkgirl does not meet cape. So the only ones that have both of those properties are Martian Manhunter and Superman. If at this point you would like to try this on your own and come back and check, please pause the video, give it a shot, see if you can do these, and then come back and check it. If you've decided you're not going to do that, or if you did pause and you're back already, welcome back. Let's continue on. So F is a union, or sorry, F union M. I shouldn't say F is a union. F union M. F and M are flying in masks. So which characters meet one of those criteria? At least one of those criteria. Martian Manhunter flies. Green Lantern flies. Wonder Woman does not meet either criteria. Superman flies. Batman has a mask. Flash has a mask. Hawkgirl does both. And for the intersection, which ones have both criteria met? Martian Manhunter, no mask. Green Lantern, no mask. Superman, no mask. Batman, no fly. It's Flash, no fly. I think it's just H. I think she's the only one. Hawkgirl is the only one with a mask that does actually fly. Our next ones, M union C is masks or capes. So again, have to meet at least one criteria of mask or cape. Martian Manhunter has a cape. Green Lantern has neither. Wonder Woman has neither. Superman has a cape. Batman has a cape and a mask. Flash has a mask. And Hawkgirl has a mask and no cape. Which ones of those meet both criteria? Martian Manhunter, M has no mask. S has no mask. B has a mask and a cape. F has no cape. H has no cape. So it's actually just B. That's the only thing in our intersection. And now the last one, again, if you tried to do these by looking at the letter sets above from this part up here, I think it would take you a little bit while. It's easier to actually think about what the sets are defined as and go through. So A union, B union, C, which by the way, ABC is coincidence that it worked out this way. But those would be alien, boys, capes. So anyone who meets at least one of those criteria. Martian Manhunter's a boy. Green Lantern's a boy. Wonder Woman is not a boy, does not have a cape, and is not an alien. So she's not in the list. Superman's an alien. Batman has a cape. Flash is a boy. And Hawkgirl is an alien. So the only one on here that doesn't meet any of the criteria of being a alien or a boy or have a cape is Wonder Woman. Now the next part is ones who are aliens and boys and capes. The Martian Manhunter is an alien boy with a cape. Green Lantern, no cape. Wonder Woman didn't meet any of the criteria. Superman is an alien boy with a cape. Batman's not an alien. Flash is not an alien. Hawkgirl's not a boy. So I think that's it. Okay, so that's pretty much how we apply these ideas of sets, things in sets, intersects, unions, and then the other terminology that we learned. Now let's actually go to some problem-solving type problems. Skip down to a whole new page here. And we're gonna basically make some Venn diagrams with some information. Now, this is one that I like to do in class, but obviously it's very hard to get immediate feedback from all of you since this is a video and I'm not actually currently with you. But I collected this data from a previous class in my notes, so let's just use it. And it was a class of 30 students. So we're going to define three sets, B, C, and P. And B is students who have taken or are taking biology. C is students who have taken or are taking chemistry. And P is students who have taken or are taking physics. So I'm going to label my three bubbles here as B, C, and P. By the way, if you label them immediately on the inside of them or immediately on the outside of them, as long as it's obvious what you're referring to, it's fine. And if we want, we can actually put an S up there for the universal set, although it's often just assumed because it's in a big rectangle. So no problem there. By the way, I didn't draw a specific different rectangle because the table itself actually put the circles within a rectangle. So here was the information I got from the class, and I just got my class to raise their hand for each of these and said, who's taken biology? And 17 students put their hand up. And then I asked who's taking chemistry and so on. And I will point out that getting students to actually pay attention to these questions long enough and answer correctly is like pulling teeth. So these examples, when we did it in class, actually took a significant amount of time. But luckily, I've got the data all here, so that's all we need. So here's the information that we've got. 17 students take biology, 16 are chemistry, 15 are physics. Again, if you think about that, we're already way over 30, but that must mean that some of these students are taking more than one. So they're getting double counted. The number of students that are taking biology and chemistry, meaning, again, this is the intersection, so it's both criteria have been met. They're bio and chemistry students. There's 8 of them, 7 students that are bio and physics, 11 students that are chemistry and physics, and 6 students that were biology and chemistry and physics. And we want to see if we can use that information to fill out that Venn diagram and then answer those questions at the bottom about the different union numbers. So basically the first one that we want to find is how many students are taking biology or chemistry. So they meet at least one of the criteria, but not necessarily both. Possibly both, but not required. All right, here's how we're going to approach it. I'm going to use a couple different colors here, and unfortunately the diagram is going to get a little bit messy, but hopefully not so messy that we can't use it. And actually, I probably will do some erasing just so we don't get too confused. Let's start off with the number of students taking biology, which is 17. Now, a whole bunch of people are going to want to write 17 right there. The problem with that is that that's the people that are taking biology and nothing else. They're inside the biology circle, but they're outside chemistry circle and outside physics circle. And I don't know that that's true because if there's any numbers in this spot, or this spot, then there's going to be actually more than 17 students taking biology. So I can't say that that is true. What I can say is that those 4 possible areas have to sum to 17. And summing to 17 is a very difficult thing to do because I could break that 17 up in a whole bunch of different ways. So I can't start there. Likewise, I can't start with one of the football shapes. And again, I'm just going to kind of highlight this to show you what I mean by a football shape. So I'm going to refer to those as footballs. And then finally, I am going to refer to this part in the middle as a fat triangle. It's a triangle, but it's kind of bulging outwards. Okay. By the way, if anyone takes the fat as being a derogatory statement, I need to let you know that I'm a rather big boy. Yeah, I do not mean it derogatory. I'm just trying to be descriptive. So when it comes down to it, the easiest way, the only real way to start these is to look at the intersection of all 3 things. So the number of people taking biology and chemistry and physics is 6. That 6 goes right there. That 6 is inside the biology circle, inside the chemistry circle, and inside the physics circle. From there, I want to use my intersection between any 2 sets to tell you the number that it's in within each football, and then we can fill in those three. I don't want to call them the fat ones. They're more like the Star Trek logo things. The three pieces of football that haven't already got a number on them. So if we look at the number of people in biology and chemistry is that football that's kind of in the center at the top. There should be eight people. So in order to have 8 people in this football, there's already 6. So I have to put 2 more up here. So there's my 8 people that are biology and chemistry. Similarly, biology and physics is going to be kind of the left football. Has to have 7 people in it. There's already 6, so there's now 1 more. And then our third football has to have 11 people in it. That's chemistry and physics. It's already got 6. It needs 5 more. Now, finally, I go back to the original 3 pieces of information. The number of students in biology is 17. So that biology circle has to have 17 total people in it. There's already 9. 6 plus 2 plus 1. So that means that we're going to need 8 more. And then similarly, chemistry has 16 people. There's already 13, so there should be 3 more. And physics has 15 people. There are already 12, 6 plus 5 plus 1. And that means that there has to be 3 more. Now, once we've done that, we can look at that entire diagram and say how many people total are inside those bubbles. And this is basically the number of people that are taking one of those 3 sciences. And I think if you add them all up, you're going to get 10, 28. 28. So we got 2 on the outside, which means there are 2 students in the class that are taking none of the sciences. So maybe they're art students, maybe they're pure math students, maybe they're something else, but they're not taking any of those 3 sciences. And once we're done that, everything inside the Venn diagram should total the universal set, which was 30, and I believe it does. So now we can say things like the number of students in biology or chemistry. I'm just going to erase that weird football shape there. And point out that biology or chemistry means they meet at least 1 criteria. Ooh, I chose crayon. Guess we're doing crayon now. Okay, so that's the biology or chemistry. And the total number of people that are in biology or chemistry is going to be 1025, I believe. Now this one is one of those ones where you can do direct or indirect reasoning, even though this is a very simple problem. I could add up everything that's in that red weird shaped bubble, or I can just say there's 30 things total and there's only 5 people outside of that weird shaped bubble. The 3 bottom that are only taking physics and the 2 that are taking none of the sciences. So I think it's easier to add up 3 plus 2 and subtract it from 30, but your call. The next one we want to do is take a look at biology or physics. And I'm not going to circle that one, but biology or physics is a bubble that basically contains anyone in one, either, or both. And that will exclude, again, only 5 students, the 3 that are only taking chemistry and the 2 that are taking nothing. So there's 25 in that bubble as well. Chemistry or physics, it's only going to include everyone except the 8 sole biologists and the 2 non-scientists, so that should be 20. And the last one says how many are taking biology or chemistry or physics, and that's going to be everyone except the 2 on the outside, so that should be 28. And if you add up all the numbers within the circles, you should get 28. Okay, that was a lot of work, but we figured it all out. Okay, we're going to look at another question which looks like the same thing, just another example identical to this one, but it's actually quite a bit different. Its approach is quite a bit different, just its layout looks the same. And for this one, we're going to look at students who are athletes, club members, or dancers. And the way I defined this in class, and we had to spend like 10 minutes with answering questions about, well, what if my whatever. Um, so we considered anyone an athlete if they'd played a high school sport currently or in the past at any grade, but it had to be a high school sport, not a like city league something, junior A hockey, nothing like that. Club members, anyone who is in a school club currently or previously, and dancers, specifically anyone who's gone to a high school dance. So not necessarily taking a dance class, but gone to an actual high school dance. And the data that I collected was the following. So the number of people that said yes to being an athlete was 22. Number of club people was 17. Number of dancers was 16. Now this is where it got weird because students are not good at this union idea. I said, how many of you are an athlete or a club person? And I had a very few people put up their hands. And I said that's not possible. Like, there's got to be more of you out there because 22 people met the criteria of being an athlete. More than 22 people have to meet one of the two criteria of being an athlete or club. And I said, so how many of you are in the union? And a bunch of people said no because they're like, no, I'm not in the union. I'm not an athlete or a club member. I'm both. And we got to remember, union means meets at least one criteria. Meeting both criteria is fine. You're still part of the union. So there were 27 people that were in that union, 25 in the union of athletes and dancers, 23 in the union of clubs and dancers, and 29 students in the union of all three of those things. So I think without too much trouble, we can conclude that there's one student who is not in any of those three. Um, I think that's kind of obvious, and it's also kind of an important clue on how to approach this one. The last thing I'm going to do before I suggest that you pause and try this on your own or think about this on your own is I'm just going to label the different bubbles. I'm going to call this one the A bubble, the athletes, this one the clubs, and this one the dancers, and it will put an S up there for the universal set. Okay, so my one clue to you before I let you try this one on your own is if I scroll back up to the first one, the information we got here, we were given information about all the intersections, not the unions. And we started in the middle of the diagram and we worked out, and the last thing we put in the diagram was this 2 down here. That was the last thing that we could figure out. This one, we're not given intersections, we're given a bunch of unions. And the first thing that we found was that little 1 in the lower corner. So I'm going to give you some time to think about it and see if you can figure out how you might approach this problem. And I will say that most students do struggle with it, so don't feel too bad if you were one of those students. Okay, so I'm going to change colors here to try and best explain this stuff. This one, you can't start with the middle part because you don't have any information about the intersections of things. So we're going to do something a little bit backwards. I will point out that besides knowing the number of people in A, C, and D, we know the union of A and C is 27. So the union looks like this. So that there is going to have 27 people in it. However, that area is broken up into 1, 2, 3, 4, 5, 6 different sections. And I have no idea how to break 27, what's the number there? A and C, yeah, 27 into all of those different sections. What I do know how to do, though, is to say if there's 27 people in there and 1 down in the outside group that's not in any of the bubbles, and there's 30 people in the class total, then I've already accounted for 28 of the people. 27 in the bubble plus that 1 outside everything, meaning that there are exactly 2 students left who have been to a dance and have never been part of a team or part of a club. Similarly, just get rid of that. I'm going to go back to my actual pen instead of my crayon. If I know that there are 25 people that have been in been an athlete or gone to a dance, maybe my crayon was better. 25 people are within that bubble, then that means that there are 6 outside. The one in the bottom corner that's already accounted for, and 5 more. And then in much the same way, just to change up my color a little bit here, let's go with green. This bubble here, which is C and D, has 23 people in it. Those 23 people leave 7 on the outside. One of them's in the corner. The remaining 6 must be there. Okay, so we've filled in a fair bit. What else can we do? We know that the number of people in, let me see here, where should we start? Let's start with A. So the number of people in A is 22, which again doesn't help me break it down because other than that 6 there, I know that the remaining 22, the remaining 16 have to be broken up into those 3 other pieces. But I do know that everything outside of A must total 8, right? Everything outside of A has to total 8 because A is 22 and there's 30 people total. So outside of that circle, there should be 8 people, and I see 5, 6, 7, 8 already accounted for. I'm just going to pause for a second because I think I may have made a small error and I don't want to mess this up because they're very time consuming. Oh, I see it. I see it. Okay. So we did make, well, I made. If you were here, you would have yelled at me. I'm sure you would have. My A or D, which had A or D should have 25, so there should be 5 people outside of it. I put 5 and 1. There should only be 4 there in that corner. There we go. Now there's 5 people outside the A Union D bubble. 4 of them that are only taking chemistry, 1 that is only taking, or not taking any of the 3. Okay, now going back to where we just were. My apologies. The number of people at A is 22. That gives us 22 people inside of A, 8 outside of A. We've already accounted for 4, 5, 6, 7 of them. There must be 1 more right there because that's the only region outside of A that hasn't been accounted for. Okay, now we're going to do the same logic for C. C has 17 people in it. Outside of the bubble, C should have 13. We've already accounted for 6, 7, 8, 9 of them. So we have 17 inside of the circle, 9 already outside of the circle. That gives us 26. There should be 4 more that go right there. And now we can actually fill in either of the remaining 2 spots. I think the easiest one to go to is just D. D is 16, and if I look at the D circle, there's already 4, 5, 6, 7 people in it, which means that there must be 9 more inside of D. And then if I look at the A and C, the A or C, I get 27. Actually, sorry, let me go to any of the others, really. If I go back to A with 22 people, inside the A circle, I already have 19, so I'm going to need 3 more right there. And I'm just going to double check to make sure that that gives the right number for C as well. Inside the C circle, it looks like we have 9 plus 1 plus 3 plus 4 is 17. And yeah, we have 17 people in the C circle. So I believe that works. I think all our numbers are now correct. Okay. Now let's see if we can actually answer the questions based on our Venn diagram. Number of people that are in A and C, so they're athletes and club members. That would be the middle football, the 3 plus the 9, so it's 12 people. Number of people who are athletes and dancers, that's kind of the left football, the 4 plus 9 is 13. The number of people that are C and D, so clubs, members, and dancers, that's the right football, 9 and 1 is 10. and the number of people who are part of all three of those groups. They are dancers and club members and athletes. There's 9 of those people. And then we have our one poor person that doesn't get involved in anything, and maybe they just need a friend. We should find out who they are and be nice to them. Okay, I'm going to stop there. That one's about as tricky as these get, by the way. Most Venn diagrams we do are going to be a little bit simpler than this. I will point out that in our next lesson, we're going to look at something called principle of inclusion-exclusion, which is still a very important idea for set theory, something you could probably logic your way through even without doing the lesson, but once you've seen it, it makes questions a little bit easier to solve. So we're going to stop there. You're going to try some homework problems, and then we're going to meet up for our next lesson. Until next time.